Welcome back to Boost and Road Designs, another Spooky Town repair video for you. This time we're cracking into the Mount Gloom Observatory. So my goal today is to kind of like baseline this piece and just, it's about 10 years old for me, and just fix a multitude of big and small problems and just get it ready for a few more turns in the villages coming up. So this format will be a little bit longer because I'm kind of trying out some different ideas as I put videos up on the channel, but I mean, I shoot these videos as I'm actually doing the repairs. So the priority for me is always like getting the work done and trying to enjoy the hobby. So I'm still trying to figure out like how to get good shots and make things clear. So I'm also, putting up the content and other videos like this with the mindset that always drives me to YouTube for this type of content, and that is like some future stranger who really wants to restore a piece for themselves or for a family member or whatever reason. So if a random Google brought you here and you want to see how this thing comes apart and maybe how it goes back together and what you can and can't do, hopefully this video will be helpful to you. So on my piece though, the Mount Gloom Observatory, the skull, turret, telescope, whatever, doesn't rotate. It has no music when you turn it on. Some of the LEDs work, like the green and yellow LEDs work, but the lightning white LEDs that strobe like a lightning effect don't work. There's little decorative gears on like the neck below the skull that don't work or they're missing, and the power plug panel is missing. A bunch of small stuff's broken off, and then although it was working when I started, halfway through the repair here, the LED in the eyeball of the telescope stopped working. So we're gonna crack into it and do some initial disassembly. Break out your heat gun for this one. I know I had to repair this piece like when I bought it used 7-8 years ago or something. I do vaguely remember kind of cracking into it, but pulling off the bottom panel, you get to that board. This is the main board. It's going to be kind of cause of and solution to all of our problems, but a lot of hot glue sort of connects the board is hot glued in to the base there, and right away I'm kind of zeroing in on maybe potentially some broken wires and that little, see that little guy right there, that's the blob chip. We're gonna come back to that in a few minutes here, but that vertical short little green board with the black splotch on it, that's gonna be kind of an issue coming up. So really though, because the motor wasn't turning, I tried to crack into the main internals, the mechanicals of this thing, so more hot glue kind of connects the inner, mostly plastic pieces with the porcelain shell. So kind of work that out, being really careful with the wiring and of the board. But in order to pull, it's all connected with a shaft there, to pull it out from the bottom, you have to take off the skull. So I don't know, that gear comes off. I used a hot glue gun. Some of them might have like super glue gluing the head on, so they could be more difficult to get off, I'm not sure. But this one came off pretty easily. There's a little JST connector to disconnect the LED that's in that telescope. So some other little balcony comes off with some glue. Just carefully pop that off, and then you can unplug all of the connectors on the board and thread them out. So I call the center part the wedding cake. You'll see why, but that can come out carefully. And some of the wiring can be disconnected like I showed, and some of it cannot be. So it's a little bit tricky. All these like twisted pairs, the green and white, yellow, white, black, white, those are all for the LEDs, like green for green, yellow for yellow, and white for white. Those are soldered directly to the board, so they thread kind of through the rim of the wedding cake there, but they can't be easily disconnected. But the motor connector, the potentiometer, the power switch connector, speaker connector, that stuff can all be unplugged, and getting some of that out of the way is pretty helpful. This piece is also kind of fun and weird because it has this slip ring device, and there's other Lemax pieces that have this too, but it allows the free rotation of that shaft without causing the wires that power the LED from getting twisted, because if it just spun forever they would become hopelessly twisted. So it's this weird little mechanism that lets them spin free, and the wiring for it is a little delicate, so we kind of track, see the way the wires get kind of fed up through the various holes and recesses to keep everything semi-organized. But here's kind of my pro tip for taking these types of pieces apart when there's lots of screws and lots of different fasteners and a lot of them are different, is I'll go around and pre-label all of the various spots where there's a fastener, a screw, whatever, number them, and then I have a bin or a tray, and I've numbered the different bins. So then when I take out all the ones, they go into the one, take out the twos, they go into the two, and it's a lot easier for me to keep track, and sometimes it goes back together. So lots of screws on this to kind of separate these different layers of the wedding cake. You can see the kind of shaft part that's connected to the skull up top. That's coming off with a few screws. Those are like red wires there are for the LEDs that go down to the slip ring. And then this is really gets a little intricate with, there's a small metal shaft in there with a small gear that gets driven by the other gears, and that small gear and shaft drive the decorative gears, the green and gold gears on the side there. So I needed to, this is after I had kind of gotten them fixed up, I reshot some of this footage, but I'll show you how that all goes together in a few minutes. But this entire sort of stack of pieces that is all layered up is interesting in that the order of operations is very important. You can't get certain parts apart until other parts come off, and vice versa. When it goes back together, there's an order of operations here. So hopefully some of the footage might help you if you ever need to get your own piece up and running. This is one component of the slip ring, those two metal tabs that get soldered to the wires. There's that shaft again that turns the gears on the side just for fun. And then this is the other inner workings of the slip ring. Those two golden concentric tracks right there are what those tabs run on, and that provides the power even though it's spinning. And there's no solid connection. It's kind of, they just sort of contact and get dragged in a circle pattern to get the positive and negative for the LED. So it's really cool. Underneath there's the motor and transmission, the belt. The issue with this thing not running at all is, it's got to be the motor, kind of was my first thought. So digging a little bit deeper to access the motor, these two wires came back to haunt me a little bit. The yellow and white wire there, that's for the slip ring. It's very delicate, and they're not, they're just easy to break. So take care. But we can start to separate out the transmission and motor, getting that apart. I did a test where I just tried to run power from a power supply, put 3.5, 4 volts to the motor, and it's not really turning. If I really kind of flick it and spin it with my finger, sometimes the motor and transmission gearbox would start to turn. There it goes. But it was very intermittent. So it could be that the gearbox is stuck and the motor can't turn it, or something's wrong with the belt, or the gearbox is too tight and squished together. So it's not too difficult though to kind of keep chugging on this and see if you can diagnose it a little bit more. The transmission, or the gearbox and motor combination, can come out with a couple of screws. And then from there, it's relatively easy to pop off the belt and determine if it can run without the belt. And you're sort of separating the motor from the transmission and the gearbox. So I can flick it and it'll run, and it runs pretty smooth. But with the belt off even, so now there's no connection to the gearbox, the motor was behaving kind of the same way. It would run sporadically and kind of weakly. So it was really just time for a new motor. This is, not uncommon. So just keep an eye on the way the motor wiring gets routed through there, since it's going by the gearbox. If you kind of don't sneak it through the little holes where it was originally designed to go, there's a danger that the wiring would get entangled with the gearbox. But a few more screws, you can separate everything else out, take the belt off. Obviously check if you have a device that doesn't turn, check the belt, make sure the belt's present, not broken. And then just 2 screws pop off or release the motor, and then you need to pry off the pulley from the shaft of the motor. Just press fits on. This one, several of them, they have they're sided, so there's like a bump on one side and the other side smooth, so just pay attention to the direction it goes. With the motor out, the gearbox on this one was really, really smooth. But I also noticed too that the pulley for the motor was had a lot of gunk and buildup, like rubber from the band or something, and there was a sharp part on the pulley. So I just used an emery board to smooth that out, wipe off any grease on the belt, and then there's just pick 2 holes. That's a new motor. Put the part number up there. Put a link in the description of what I use. They're just on Amazon. Get a bag of them for $15. Again, just watch the way the wires get kind of routed in there, and then the 2 screws go back on. Tighten them up by hand, and then press the pulley back on the shaft, paying attention to kind of which side goes down, which side goes up, kind of thing. I forgot to put the belt back on. Did you notice that? It's okay, you can sneak it back on later. Just watch the wires. And you're just reversing the process here. It can be a little frustrating, the order that things need to be reassembled. I don't know. I don't think it's... If you are desperate enough to come this far to fix one of these machines, you will figure it out on your own. You can watch this video for some tips, but just be patient. And then just sort of rebuilding the layers of that wedding cake. And if you do find that you can't access some screws because it doesn't make sense, just probably just got things a little bit backwards. Just take your time and retrace your steps. But so the other thing with these slip rings is that they can get dirty. Here's some old footage. It shows some tarnish, corrosion. So some contact cleaner. And also the 2 pads, the 2 metal prongs that are on the other piece, can be cleaned with contact cleaner. So if you're ever dealing with an issue with a piece like this, check for that and clean those up. These are the 2 wires for the LED that go to the underside of the slip ring, and I think they actually both broke on me at some point. So just to show you how I go about doing that, I use a solder sucker tool and heat up the solder, suck off the old solder, poke the wire through the hole, and just add some more solder to it. It's fast, but I'll sped up maybe too much. But definitely something to consider if it's not working. What could be causing that? So the gears on the side here, I know they originally worked. They broke at some point. They were falling off. So I still happen to have the two gears, the original gears. I just didn't have the shafts that they wrote on to fit in. So I have a little collection of brass or steel shafts that I got from Bamboo Labs or something, all different lengths and sizes, but 2mm shaft is a press fit onto the copper colored gear, and then I ended up using, I think, a 2 millimeter shafts. And a 2 millimeter shaft for the green gear lets it spin freely. So just to get a better idea here, that steel shaft up the center of the tower turns a little, I think it's a crown gear, a little white plastic gear that's a press fit onto that shaft, and that gives the kind of 90-degree turn to drive the copper colored gear. And the 2 millimeter brass shaft that I had was a little bit too long, so I just marked it how, like, kind of the extra length, and then used the Dremel tool to cut off the excess. But 2 millimeters worked good. Smooth that out, press fit on the little white gear, and then we've got kind of the turning action happening. So the steel shaft, I don't know exactly if it's critical, but it looks like there's like slightly different lengths of the gears are the same, but they're pushed on to different lengths. So make sure that's right, make sure the gears line up. There's a little spot to capture the upper gear, and then the lower gear drives within the base unit. So for the green gear, I use 2 millimeter self-tapping screws. It's supposed to spin free, not tight. So then the copper gear turns the green gear. So quick test of the kind of wedding cake, slip ring assembly, the gear assembly, just to make sure it's all working. So new motor, cleaned up the slip ring, and fixed up the gears. So I was really happy with that. It's a subtle detail, so don't stress if it's not kind of going your way. But next up is, at some point, I don't know, like the power adapter totally fell out of this unit, and I threw in another power adapter with just a ton of hot glue to hold it in place. So I wanted to fix that back up, so I cleaned out all the old hot glue that I was using, took some quick measurements, and just made a quick 3D print of an acceptable sort of power panel, and then some hot glue to mount the new power panel in place with the new adapter plug and spot for the wire for the potentiometer and power switch to come out, and then some hot glue on the inside to get that sealed up. And then, I think this is kind of the big one for me, is I had realized at some point that the lightning LED effect, the white LEDs, weren't working. So you can see the green LEDs that are just always on, and the yellow LEDs that are always on, those work. But anything that is not always on, so like that the white LEDs are kind of like an effect, like they strobe on and off to a preset program. Those are going to be handled differently than the solid always on LEDs. So I did some checking, and I could tell, I don't have film of it all, but I could tell that the white LEDs worked, but it started to dawn on me that the blob chip, the little circuit board that's mounted onto the main board here, was the culprit. So those are called chip on board, COBs, and they are custom pre-programmed circuits for delivering like custom music or custom lighting effects that are unique to an individual piece. Mount Gloom Observatory, that has a soundtrack, it has a particular strobing effect. On the main board, the LEDs get soldered, like the ones that are always on just get soldered to different resistors, but the black and the white wire go to a ground. The white goes to a ground, I think, and then the black wire goes to a different pad in the black arrow, and that pad is then sort of controlled by, I think it's a transistor, but that transistor is then signaled by the blob chip, the chip on board, at a specific kind of like rate with a specific timing to deliver the strobe kind of lightning effect. So it's pre-programmed, pre-timed lighting to deliver that kind of effect. That blob chip again, the music is dead and the lightning is dead. The blob chip is dead, and those are not replaceable. You can't get spare parts for those. I got some inspiration from this channel, Caden's Modifications, where he's done kind of restoration of these types of effects using Arduinos, and in this case I'm using this Gemma M0 from Adafruit. It's just a little, it's basically a miniature computer. It's the size of a quarter, but it's a little programmable device that you can use to do all sorts of electronics tasks, but certainly we can use something like this to control the LEDs that are built in to the piece. So we're going to try to restore the lightning function by sort of bypassing the blob chip, bypassing the built-in lightning effect, and sort of make our own. So there's a lot of choices you can use for this type of situation. I use the Gemma. What's nice about it is it has a little JST port for connecting power, and then the power that it requires is 4 to 6 volts DC, which is perfect. That's right in the range of what the standard Lemax power adapter is going to deliver. It runs code that comes from Circuit Python is basically Python language. I don't code. I don't know how to do any of this. You can also program it to use the maker code or make code, where you can kind of just shuffle these blocks around. It doesn't come like that actually out of the box. I thought it did, and I thought that would be super easy to program, but you do have to kind of do a little work to reflash a device like this to get the make code operational. So I kind of panicked, and I backtracked, and I went back to the Circuit Python, thinking about how hard will it be to learn, to kind of learn the code to get basically just get an LED to flash. So I have zero programming experience, but the Adafruit website does make it as easy as possible. So their guides, their getting started guides, are really good. And then all I ended up doing was just Googling up CircuitPython code to simulate lightning with a single LED, and lo and behold, you can get results. And then all you have to do is copy. They put the copy button in for you. You can copy that right into this editor that is included, and then you save that to the device via USB, and that's it. And then you can even get more specific. Like, ultimately, you have to tell it which pin to use, and then I even put in, like, for a Gemma M0 on pin D0, and it writes the code perfectly fine. So, if you already know how to do Arduino or Python or anything similar, this is probably a piece of cake. But I just get a little frustrated trying to learn all this stuff. So you don't have to go out and buy the Gemma. There's other options. I'm sure there's 100 different ways. The Gemma is way overkill for what we need to blink an LED, but it's only like $9, so I thought it was a good way to go. So here's the Gemma. You can see it's pretty small. A USB is used to program it, and then it has this built-in little power plug that I just kind of cut a pigtail onto the existing Lemax power adapter, soldered on positive and negative, kind of splitting the power to go power the Gemma, and then the other one powers the board just like normal. So, and then we just need to solder the white wire to D0 and the black wire to the ground pin on the Gemma. Really the only thing we have to worry about is putting a resistor in. So I'll explain that in a second, but just a proof of concept. I had it pre-wired, it's an LED that's pre-wired with a resistor, and I just clipped it onto the D0 pin and the ground pin, and I loaded that little program that I showed you on via USB, and then I just powered it up. And then if you watch carefully, it doesn't sound very bright, but that one white LED is going to start blinking, strobing in a randomized fashion, so like lightning, and it simulates very, very close to what the original Lemax kind of effect was. In fact, it's even more random because it's truly random, whereas the Lemax one I think is just on repeat. So I just needed to go at some point and steal the black and white wires for the LEDs. So I just desoldered the white wire from the original board. Kind of stole the wire there. The black one had already broken off. That's why it's off. It snapped off during disassembly or something. And then the only trick here is that it's important to put a resistor in line. I used the black wire. I don't know if it matters. I used a 40 ohm resistor or a 20 or 40 ohm resistor. Don't quote me on that. Do a little research. It might be that a slightly higher resistance value is recommended. I know it protects the LEDs, but I think it also protects the Gemma too. I just, might have made a mistake here. I used a 20 ohm resistor, which maybe isn't the best move, but it seems to work right now. I don't know if the longevity, again, for $9, I'm not too worried about damaging too much there. So anyway, this resistor has to get soldered sort of in line with one of the wires. So just splice it in, solder it up, put some heat shrink over it, and before I did that, I just clipped it in temporarily just to confirm that the Gemma is now running the white LEDs on the Mountain Gloom. So you can see it kind of strobing there randomly. Turn the lights out, and yeah, it looks really good. Like, it looks as good as the original. So I was very, very happy with this. So yeah, we've kind of restored that lightning effect. It's other pieces have lightning, so it's not like your village may or may not need this. But I was kind of a little sad when I realized it wasn't working, so I like to have it back here. Still, the music doesn't work. That's the real downside, but it's probably not, well, it's definitely not out of the question to rejigger the Gemma probably to play. Like, you could probably upload, if you had an MP3 or something, or sound file of the soundtrack, you could probably get it to play through the speaker. I don't know. But then I just went through and soldered up sort of the final wiring for the Gemma. So just use a lot of flux and the white and the black wires from those LEDs, and then the resistor in line. The Gemma is pretty small, but I wasn't going to use the speaker anymore, so I did pluck the speaker out of the base, saved it for something else, and then made a little mount for the Gemma, basically where the speaker used to be. Again, other boards are even smaller. You could probably tuck them almost anywhere. The Gemma is funny. I think it's actually designed to be like sewn into costumes and stuff, so you can, if you want like lights on like a Halloween costume or something. So it's kind of an unusual size and shape, but again, kind of the first thing I stumbled upon. So carefully started to reorganize using hot glue and just careful just tucking the wires in the right places here, get everything back into position. Because it's a moving piece, it does have that main twisting kind of shaft in there. You do have to kind of keep peeking your head in. You look in and see if any of the wiring is in danger of getting entangled and twisted up. And then I had the original cover. I put that back on with some screws and just give it a final test. So we've got the main motion back, the turning is back, the gears are working, the lightning's working, powered by the Gemma. Really, so far so good. At some point though, I had realized that the light in the eyeball or the telescope there had stopped working. And I know it's on the video in the beginning here of it working, so I don't know when it broke, but I really wanted to fix it. So I started to explore how to get this telescope out. I don't know how it's attached. It's glued in somehow. I don't know what kind of glue. I used a super glue debonder and brute force, but it's really it's really glued in there. So I let the debonder sit for a while. I really tried to crank it out of there, to crack it loose. It was very, very stubborn. I did try a heat gun at one point, a few times. Didn't seem to do much. I went back to the debonder. With the debonder liquid, it's chemically dissolving the glue, so it softens the glue up over time, and I think it just takes a while to work. I tried small pliers, and then of course I tried bigger pliers. Yeah. Eventually, after enough debonder and enough time, I think I ended up just letting it sit for like an hour, and some very, very careful action with the pliers. It's like being a dentist or something. Eventually you can kind of crack that loose, you'll hear it, and then take out the telescope. Job's not really done though. The telescope is really hard to get apart. It's two pieces kind of glued together. So again, more debonder and some little spudge sticks to kind of try to separate those two halves. It took a lot of patience. Too much debonder, things start to actually just dissolve. So you have to be very judicious and patient with it. But that exposed finally the LED, which is just kind of as I expected, just a basic LED hot glued in. It looked a little crispy on the inside. And then eventually I went back and realized I found that the two wires that run up the shaft were getting pinched right either at the top. They either got stuck in the gears or kind of wedged, and the insulation was just old and cracked. And so those two wires had shorted out and killed that LED, I guess. So disassemble the shaft again and had to go fix up that part of the wiring and the connector. So you get very intimate with kind of getting this thing apart multiple times. But I just soldered on a JST connector, heat shrink tubing on the joints, and then hot glue to sort of tuck the wires back in their spot. They've got little cutouts, but little hot glue so they don't go anywhere. And then I started testing out some different options for the eyeball, and I had these little 5mm pre-wired LEDs. They're not, is it 12 volt? I don't think they're 12 volt. I think they're 5 or 6 volt. But they are slow RGB changing, so they kind of go like a rainbow pattern, red, green, blue, everything in between automatically without needing, I mean, I could have run off the Gemma too, but I could use like a NeoPixel or something. But this is a really cheap, easy, quick solution to put a little pizzazz into the eyeball wiring. I had to fix the wires to the board. One goes to a ground, one goes to that middle pad, and then a quick test, and you see it starts out red, then it goes green, and it cycles all different colors in between. And then I started out just with some hot glue to kind of tack the telescope back into the eye socket. But I'll show you in a minute. That was a little bit squirrely, and I did use hot glue to get the head, the skull, attached back to the base. That I think is okay. But yeah, I was digging the color changing eye. I think it's pretty wild. To get the eye telescope permanently attached, I was playing around with the UV cured glue and putty. I think I ended up using the putty in this case. But these are neat. So they come with a little UV ultraviolet flashlight kind of tool, and wear gloves for sure. These chemicals are kind of nasty, but I just use the putty to start with and kind of pack that into the eye socket. Need a little bit of extra reach to get down in there, so I just used a pipette tube here, and I just pack in some resin into the, around the joint. Use a popsicle stick or something just to kind of get that in there, and it looks kind of whitish. It's clear, kind of off-white, and then you shine it for like just 5 to 10 seconds with the UV light, and it cures like that fast, and it's really, really strong. It's like just becomes like permanent plastic. So I was really happy with that. It feels exactly the way it felt originally. And that is earlier when I just had the hot glue, which it started to bother me that you could see the blobs of the hot glue in there. That's why I ended up plucking those out and putting in the UV resin. And then just some miniature modeling paints, dark colors to disguise the damage done for that. And then, it was the super glue debonder strips paint really, really easily. So I had accidentally spilt some on the forehead of the skull here, and it took the paint right off. Not really noticeable, but while I was here, I just took some more modeling paints, mixed up some different colors, and blended all that back together, so now it's really, really hard to tell that anything happened. And getting ready now to button it all up. This is some self-adhesive neoprene that I'm using. I actually don't like this brand. It's not very sticky, so I have to add some spray adhesive to it. So if you're getting some of this, I wouldn't recommend this exact product. But I have a little finishing touch here. I created a little 3D printed stamp. Give it a little maker's mark here for Boost and Road Designs, and then I find myself going into these pieces frequently enough. I sort of start to wonder, like, what did I do on this? And I'm trying to keep notes, so I just grabbed a silver Sharpie and just started making some notes to myself, kind of future self notes. Change the motor. This one has a gemma, stuff like that, just in case I'm lose track of things and need a refresher. Even this one, I know I had replaced the motor actually already on this once, so kind of nice to know how often this is happening. Stick on the neoprene. I press it down with my little rolly tool here, and then just trim up the edges with a sharp utility knife, X-Acto knife. Overall, it's looking great. I mean, it's kind of back to the factory almost, with the exception of the music. So we fixed the motor. We got the lightning effect restored with the gemma, or similar microcontroller would work. We put in that RGB changing LED in the eye, just for fun. We got those decorative gears fixed and fixed up on a bunch of other little broken bits and pieces here and there. So I'm really stoked. I hope this helps someone get one of their pieces worked up, and definitely appreciate looking at these pixels. Is it worth it? On this one, on the Boost and Road Designs, is it worth it meter? I would say actually kind of like not really. Like this is a lot of work. It's a finicky piece to work on, and like a few things like lightning not working or an LED out here and there. I think the piece still is cool. Just anyway, so it's a kind of it's not really a centerpiece. It's kind of a filler, and but if you're into this kind of thing, it's always kind of fun to see how far you can take it. Subscribe if you can. Again, we appreciate it. We'll do more videos for you real soon.